So here it is, the big question. Why on earth does 100-degree steam cause a worse burn than a 200-degree oven? I mean, that just feels totally backward, doesn't it? A lower temperature, but a way, way more dangerous result. So what is going on here? What's the science behind this? Okay, to really get this, let's step into a place we all know really well, the kitchen. We're going to use this everyday setting to make what seems like an abstract science problem feel very real and very fast. So, take a look at this. It's a direct comparison. On one side, you've got a 204-degree oven. You can open that door, maybe quickly reach in to check on something, and your hand is fine. But on the other side, you've got 100 degrees steam. That's half the temperature. And yet we know that even a split second of contact with that steam is an instant, serious burn. The numbers are telling us one thing, but our real-life experience is telling a completely different and, frankly, much more painful story. So the answer to this whole paradox, it isn't actually about the temperature itself. No, it's about a hidden form of energy, a really powerful principle that just changes everything. This is where the real secret is. And it's called latent heat. The word latent literally means hidden, and that's the perfect description. This isn't the kind of energy that makes the thermometer go up. Nope, this is the massive, and I mean colossal amount of energy that gets released when a substance changes its state. Think about steam turning back into water. So here's how it all goes down. First, that 100-degree steam touches a cooler surface, say your skin. Second, it instantly condenses, going from a gas right back into a liquid. And third, and this is the absolute key, in that tiny fraction of a second, it unleashes all of that hidden, latent heat directly onto that surface. It's not the temperature of the steam that gets you. It's this huge, instantaneous dump of energy that does all the real damage. Now, this incredible power isn't just something to be careful of in the kitchen. It's actually a life-saving tool in a really critical field, sterilization. And when we talk about sterilization, we're not just talking about killing everyday germs. The real mission, the big challenge, is destroying these super tough, heat-resistant bacterial spores. I mean, these things are incredibly resilient little survivors. Just trying to bake them with dry heat often just doesn't cut it. But here's the thing. To make steam actually work for sterilization, you've got to defeat two main enemies. Air pockets, which act like little insulators on surfaces, and pooling water, which just kind of gets in the way. So why are these such a big deal? Well, it's simple. Both of them stop the steam from making direct contact with the surface. And if there's no contact, there's no condensation. And if there's no condensation, that massive germ-killing energy transfer just can't happen. So for sterilization to actually work, that steam has to get in and penetrate absolutely everywhere. So what's the big takeaway from all this? It really all comes down to completely reframing how we think about heat. It's a total game changer, really. There's a quote from our source material that just absolutely nails it. It says, "It's the heat transfer that actually kills bacteria." Simple as that. And that really is the crucial point, isn't it? It's not just about how hot something is, but about how efficiently it delivers its energy. Dry air in an oven, it's pretty inefficient. But condensing steam? Oh, that is an incredibly powerful and, you could say, brutally efficient delivery system for energy. So that leaves us with one final thought to chew on. Where else does this hidden power of phase change play a role on our world? I mean, we've seen it in the kitchen and in medicine, right? But it's also what's driving huge weather patterns that circle the globe. It's even powering the cooling systems inside our computers. Its effects are literally everywhere, once you know what to look for. Thanks so much for joining me on this one.